All right, so we're going to start with Journal 7 today here with our bell work. Now this might look familiar. We learned inequalities long ago, but for this one here, it's actually that I've given you the graph first and you have to tell me the inequality, which means that you have to use those less than or greater signs, or less than or equal or greater than or equal, those types of signs. And then the interval notation is when you have to use like brackets and parentheses. So that's what we've learned so far. So looking at these graphs here, it might be easier to start out with the interval notation before we do the inequalities. So I'm actually going to fill out this part first. So looking at this graph here, notice how the 4 is here, but it's pointing or highlighted or shaded in this direction to the left. So it is pointing towards negative infinity. So I know my two endpoints are negative infinity to 4. So we always write our smallest number first, which is the negative, and then it's going to go 4, which is our highest number. We need a parentheses on the 4 because that's an open circle, parentheses on the infinity because we always use parentheses on infinities. Okay. Now let's do that with the second one here. So this is from -1, and it's shaded in this region, so it's headed towards positive infinity. And so we're going from -1 to positive infinity, in parentheses on that one, bracket on the -1. Okay. So now when we're looking at our interval notation, we've completed that part. Let's look at the inequality. So the inequality describes where x is at. So we need to use x's when we write our inequality. So I'm going to drop down an x, and looking at this graph here, x is represented someplace in this region, right? The highlighted or shaded region. So x is being compared to 4 in a way. So we need 4. It's the one that is marked. And it looks like that x is on the left side of 4, which means that x is smaller than 4. Notice how it's going to negative infinity. These numbers over on this side, on the left side, are smaller than 4, so I need the sign to be facing the 4 because inequalities face the bigger number, right? And it faces away from the smaller number. So in this case, 4 is our biggest number here. And so that's why it's facing the 4. Now, I don't need a line underneath this or an equal sign because this is an open circle. Now, with this one here, I'm going to do the same thing. I have to write an x, and the number that they circled is -1, so I'm going to compare it with -1. And you can see here that x is in this highlighted region here. So, if x is here, right, and that's -1, x is bigger than -1 because on this side of the -1, these are numbers bigger than -1. So that's why you want to face the mouth of the inequality on the x because x here is bigger. Okay. And also we need an equal sign underneath this inequality because that is a closed circle. All right, that's it for this bell work here. We're going to head on to today's lesson. But before we do that, I'm actually going to do some packet problems in the next slide. So don't put the next slide in your journals. You actually will work it out on your packet. So I'm going to be working on packet 2, and I handed that out in class on Friday, September the 6th. So if you weren't in class September the 6th, make sure you grab a packet from me. So this is going to be packet 2, page 1, that I'm going to be looking at. All right. So like I said, these problems are straight from the homework problems. I'm doing problems 4 and 5, so you don't need to put this part in your journal, okay? No reason that you would need to put in your journals. I'd rather you write this on your homework packet. So working this problem out, it wants you to write the inequality sign given the graph. So looking at this graph here, notice how this graph has 2 highlighted regions, right? So that means there are 2 places where x can be represented. So I'm going to need to write an inequality for 2 x's. So for this x here, it's being compared to -2. That's where they've circled or marked. So I'm going to drop that down, and then I have to figure out where do I open up my inequality. Do I open up towards the x or the -2? Well, ask yourself this. Here's -2, right? x is this region right here. It means that x is smaller. These numbers here behind -2 would be smaller. So x is smaller than -2. So that means the inequality sign needs to be facing the -2. Whereas this side here, we're going to drop down an x, and it's being compared to 3, right? That's the graph marked it at 3, so that's why I need a 3 here. And so notice how x here is represented on the right side. So on the right side of 3, these are numbers that are bigger than 3. And so that means that x is bigger than 3, so I'm going to open the mouth towards the x. And I don't have the equal sign underneath because these are open circles. Now, because there are 2 inequalities here, we have to combine them using OR. Okay? Because x could be in this region or it can be in this region. So that's it. All it wanted was the inequality, and now we have it. Now, this side here. So notice that there's only one highlighted or shaded region here. It's the one in the middle, right, between these 2 circles. So x is somewhere here. So what I'm going to do is I'm going to place down an x, but it's being looked at between -2 and +3. And I would want to write the -2 on this side because it's smaller, right? We typically write our numbers that are smaller on the left side and our bigger number, the 3, here on our right side. And so if you were to take a look at just the -2 here, notice how x is on the right side of -2, which means that it's bigger than -2, right? So in this case, you want your inequality facing the x because x is bigger. But if you were to face the 3, notice how x is on the left side of it. So that means the 3 is bigger. So the inequality is going to be facing the 3. And so now let's take a look and see if we need any equal signs, but these are open circles, so we don't need to put the equal signs down there. And that's it. And looking at this inequality, if you were to graph it, right, you would have a -2 and a 3. And that means that you would put the open circles here, and x is between those 2 values. This looks very similar to what we're used to. And so that is going to be, our inequality. Okay, so that was just 2 problems we did from the homework packet. Now we're going to go back to the journal. So the next slide we're going to write back in our journals here. Okay, so like I said, make sure you write this in your journals. It's talking about when solving for inequalities, you need to remember these 2 things. The first thing is when you multiply or divide by a negative number, it switches the inequality sign. So that means that given this inequality, okay, when we divide by or multiply by a negative number, we're going to switch this sign here. Now, when you're solving for inequalities, they're like you're solving for normal equations. Like if you pretend that this was an equal sign and you had to get this x by itself, what would you do? Well, we would probably need to get this x by itself by dividing over the -3. Notice how I'm dividing over -3, which means that, well, I have to flip this inequality sign because it's negative. So now it's not facing the x, it's facing the other side. And so now this is 9 divided by 3, which is -3. X drops down, and x is by itself, so this here is my answer. I've solved for the inequality. I do want to point out with this problem here, just so that we are clear. So we're going to do the same problem, we're going to do this problem very similar to the one we just did. We have to get the x by itself, so we're going to divide by 3. And this time, I'm dividing by a +3, right? This one here is a +3. So when it's a positive number that you're dividing by, you do not need to switch the inequality sign. Even though that this side here is a -9, right? When you divide, you get a -3. But because you are not dividing by a negative number, this is a positive, you don't need to switch the signs, okay? Whereas this one here, you could see this is a negative number, right? And so that's why you needed to switch the inequality. Because when you divide by a negative number, it changes the sign on the other side. Whereas when you divide by a positive number, the sign doesn't change. This was a -9, this is still a -3. Okay, so we solve for this one because x is by itself. one more thing that you need to remember, anything you do to one side, you must do to the other side. So like solving this one out, remember, we're just trying to get the x by itself. So in this case, we got to move things over. So maybe we should start with moving the 5 over since that's further away. So I'm going to add 5 to both sides. That cancels. And so we have 2x is less than 13 plus 5, which is 18. And then we are going to divide by 2. So that's going to cancel. And so x is less than 18 divided by 2, which is 9. And x is by itself, so I know this here is my inequality. All right, so now that we've gotten some practice there, we're going to do 2 problems from that packet. So on page 1, I'm going to be looking at problems 9 and 13. So like I said, don't write that in your journals. Write that on your packet. Okay, so looking at these 2 problems here, we're going to be solving for the inequality. So I need to make sure that the x is by itself. So for number 9, just like how we did the last problem, we got to get the x by itself. So I'm going to start moving things over, like the 30 here. I got to add 30 to both sides. So that cancels. So 7x comes down. 19 plus 30 gives me 49. Now I can divide the 7 over. If I divide by 7, that cancels out. So now I have, I'm just going to write it over here. X is less than 49 divided by 7 is 7. And x is by itself, so that's it. And it just wanted the inequality notation, so I can just leave my answer like this, because this here is the inequality notation. But the next problem says to solve for the inequality, but you have to write it as a interval notation. So that means that you need to write it with the parentheses and brackets, okay? So looking at this problem here, notice I have the x's here. And so I need to get the x's all on one side. So I'm going to try to move things around. Remember, one of the rules is that anything you do to one side, you have to do it to the other. So it doesn't matter what you move around first, you just have to make sure you move it to the other side as well. So maybe I'm going to move this 3 over to that side, so I have to subtract the 3x. Subtract the 3x on both sides. So that cancels. Negative 2 is greater than or equal to 4x minus 10. And then, okay, here's my x. I want to try to get that by itself, so maybe I need to move this guy over to the other side. So I'd have to add 10. Let me use a different color here. Add 10 to both sides. That cancels out. And so now I have 4x is negative 2 plus 10 is positive 8. Now I have to divide by 4. And so 8 divided by 4 gives me 2. So 2 greater than or equal to x. So looking at this here, I have my inequality, which is great, right? I have my inequality, but it wants the interval notation. Okay, now you can go ahead and try to jump from this to interval notation, but I don't recommend it, especially if you're a beginner, because it might be hard to tell what are your 2 endpoints. So I highly recommend that you draw the line graph first. So graph it first, because you're going to be able to see clearly what your 2 endpoints are. So in this case, I have a 2, because, well, this inequality has a 2. It needs a closed circle. And based off of this inequality, it says that the 2 is bigger than x, right? So here's 2. So if 2 is bigger than x, that means that x is smaller than 2, which tells me that x is going to be on this side of the graph, pointing this way, which means it's pointing to negative infinity. So that means that the inequality, or the interval notation, is going to be negative infinity to 2, parentheses, and bracket on the 2. And that there would be my interval notation. So I highly recommend, once you get your inequality, to graph it if you are asked to find the interval notation, because it's much easier to look at a graph and be able to tell what your interval notation is. Without the graph, it can be a little bit tougher. Okay, so that's my tip. Okay, now let's do one more slide back into the journal, and then we'll do a couple problems from the packet. All right, so this is our last slide here for the journal. And so let's talk about compound inequality. So compound inequality is talking about if you have like two inequalities and you attach them together in some way. So like this one here, having two inequalities attached to x, notice there's just one x here. There are two inequalities, 1, 2 on either sides of x. Anything you do to x, you need to do it to both sides of the inequality. Okay, let's kind of back up here. So here's our problem, right? If we were to just pretend here for a sec, let me get something that might cover that. Let's use this here. Yeah, let's just cover up this inequality sign here for a sec. If you were to pretend that you had to solve for this, just this part of the inequality, you'd probably try to solve it by adding 10 to both sides. So that way you could get rid of this 10, right? But here's the thing. When you do that, when there are two inequalities, you have to add it to both sides. You have to add 10 in this case to both sides. That cancels out the one in the middle where x drops down and the inequalities will drop down, and then you have to work the stuff on either side. So -1 plus positive 10 is 9, and then 4 plus 10 is 14. And so in this case here, we have x is between 9 and 14. So with this, I know it doesn't ask, but let's practice graphing this inequality here and also writing it as interval notation. So that way you guys get more practice. So if we were to graph it, right, we have two numbers here, 9 and 14. We need a closed circle on 9 because there's a equal sign for that. And then an open circle on the 14. And because x here is between 9 and 14, I need to shade the middle part here between 9 and 14 because that's where x is located. Now for our interval notation, it looks like we have bracket 9 and then 14 parentheses. And that's it. And there we go. We have the graph and interval. Like I said, when you graph it, the interval just becomes so easy to figure out. Then on this one here, it says when there are two inequalities joined together by or, there's the or. Notice how this equation is its own, and so is this one, has its own x. You're going to solve each inequality separately and then use U for union for the interval notation. So this problem here, we're just going to focus on this one first, trying to get this x by itself. So maybe the first thing I need to do is move over this positive 3. So I might need to subtract by 3 on both sides. So that cancels. 2x is less than -6. I need to divide over the 2. So that cancels. And so x is less than -6 divided by 2 gives me -3. And so now I'm just going to bring down this or since it's here in the middle. I'm going to bring it down because I've already solved this part here. So bring down or. Now this one is a lot easier to solve. I just have to move this 4 to the other side. So I'm going to divide by 4. This cancels, and x is greater than or equal to 16 divided by 4 is 4. And so now here is our inequality. But let's go ahead and graph that so we can see what that might look like on the graph here. So there are only two numbers we're working with, -3 and 4. So plotting those, remember we do it in order. You want to write the -3 on the left side and 4 on the right side. Remember, least to greatest. And so I need a open circle on the 3 and a closed circle on the 4. And if you look at this inequality here, the first one, okay, at -3, it says x is less than -3. So that means we're going to be shading on the left side because these are numbers smaller. Well, in that case, if I'm shading this side here, it's heading towards -infinity. Whereas this one here, this x is greater than or equal to 4. So if this is 4 and x is greater, we're going to be moving to the right because that becomes bigger. These numbers here are bigger, and so it's heading towards positive infinity, which makes it a lot easier to write this as interval notation, because this would be -infinity, parentheses, -3, parentheses, bracket on the 4, and then infinity, parentheses, and then we use a U for union to join these two together. All right, now let's take a look at two problems from the packet to see how, just to get some more practice in too. Okay, so it says here to solve for the compound inequality. It also says to graph the solution on a number line and then write the interval notation. I'm not going to be too picky on whether you graph it or not, okay? I'm actually looking for whether you know how to write it as an interval notation. That's a hard jump to do if you don't graph it. So even though you don't have to graph, I recommend you graph because you might not know how to do it correctly if you don't see the graph, okay? So first thing, we're going to just solve for the x. So this x is in the middle here. I need to get it by itself. So maybe I need to move over the 5 first since that's further away from x. So I need to move it to both sides by subtracting the 5 on either sides. So that cancels. So I have negative 2x. And then 9 minus 5 gives me 4 on this side. Negative 13 minus 5 gives me negative 18 on this side. All right, now notice I have a negative 2 here that I will probably need to divide off of x. But I'm dividing by a negative 2. We learned that if you divide by a negative number, the inequality signs are going to switch. So these signs, pay attention, make sure you switch them. So x drops down. 4 divided by negative 2 gives me negative 2. Negative 18 divided by negative 2 gives me positive 9. Notice that switching the signs makes the inequality make sense. Because if I didn't flip this sign here, and this was facing the negative 2, and this was facing the x, that's saying that 9 is less than all of these numbers here. And 9 is bigger than negative 2. So that's why the inequalities had to all be facing the 9, because it's eventually going to be the biggest one. So that's our inequality here. But it also says to write it as a interval notation, so make sure you do that. But I'm actually going to graph it real quick so I can see what it looks like. So we have negative 2 and 9. Open circle for the negative 2 and close circle for the 9. And you notice that x is between negative 2 and 9. So I need to shade the middle region here. And when I see this, I'm like, oh, parentheses on the negative 2, and it's going to 9 for the shaded region, bracket on the 9. And there we have it, our interval notation. All right, let's take a look at 18 here. So 18 has two separate equations separated by an or, but remember we just, solve it, try to get the x by itself. So this one I need to add 4 to both sides. That cancels out. So now I have x is less than negative 12 plus 4 gives me negative 8. I'm going to drop down this or here since I'm done solving this problem. I'm going to divide by 2. That cancels, so x is greater than 12 divided by 2 gives me 6. And so now I have my inequality solved. I'm going to graph this. This is one of those that you definitely want to graph because this is really hard to tell what those interval notation is if you don't graph. Because you're not going to be able to see those infinity signs without graphing. Okay, so on here we have negative 8 and positive 6. Open and then I guess close on the 6. And so if we focus in on this one here, x is less than negative 8. So if here's negative 8, x has to be less than, so it's going to be shading to the left. So I'm shading towards this side, so I'm heading towards negative infinity. Whereas this one, x is bigger than or equal to 6, so that means that I'm going to be shading this side where numbers are bigger than 6, so I'm heading towards positive infinity. Now that I can actually see my shaded regions, I know I have to write 2 intervals, one from negative infinity to negative 8 parentheses, and then bracket 6 to positive infinity, parentheses, and then a u in the middle to join that together. And that there is my interval notation that they want. All right, so I hope that helps you out, guys. And that's it for this journal. Anyhow, until next time. Bye, guys.